Okay, this time I'm going to talk about how to calculate the age of universe. In order to do this, what we have to know is Hubble. Mr. Hubble, he's a famous astronomer. What he found is the expansion of universe. Yeah. So thanks to that, he described. Thanks to that, we know that we are living in the expanding universe. So before that, we didn't know about that. If the universe is expanding or shrinking or becoming smaller or static, we didn't know that. But he figured out. Okay. So this is what he found. So here, this distance, we use r. This distance means the distance between the Earth and the star. So this the black point indicate the stars. So, and then this is a velocity. This is a recession velocity. So that means let's put v. So if the distance between the star and the Earth, this Earth is longer, then recession velocity become higher. So from here, there is a very famous formula. V, recession velocity, is a Hubble constant times the r. So let's think about the unit. Velocity is the h. The Hubble constant, the unit is a kilometer over s times megaparsec. And then r is m. Kilometer, actually megaparsec is looks different, but it indicates the distance, because the size, scale of universe is much bigger than this kilometer. So the astronomer, cosmologist use megaparsec a lot. Actually, this is the same thing, so we don't worry about that. So m over s is remaining, so that is velocity. And then when we calculate about time, we use distance over average speed. So if we assume the velocity, that means recession velocity of the stars area, whatever, which is a constant. If the velocity is constant, we can calculate the time of the system. That means age of universe. Then actually distance of average speed, which is let's write it down here, and distance is r over v, which is 1 over h, reciprocal of h. So if we calculate this, we can know the age of the universe. Yeah, let's do that. It's not that difficult, since according to the information, the current age is like around 70.5 kilometer over s times megaparsec. So only we have to do is arranging the unit, and then of course we have to do this, which is reciprocal of h, the 1 over 70.5 as a denominator, then kilometer is here, then s times megaparsec. Then megaparsec is a 3.09 times 10 to the 22 meter. And then yeah, we don't want to have a megaparsec, so megaparsec, 1 megaparsec, which is 3.9 times 10 to the 22 meter. Then we don't want to have a kilometer, then 1 kilometer is 1000 meter. Okay, kilometer cancel out, meter cancel out, megaparsec cancel out, and then remaining is s. But even though we get a value of second, we cannot recognize how much is that. So let's make it to the year. How do we do that? So 60 seconds is 1 minute, then 60 minutes is 1 hour. Then I continue. 24 hour is 1 day. No, 365 days is a year, 1 year. So those are cancelled out, and our minutes, second is also cancelled out, so remaining is year. If we calculate this, we can have 1.39 times 10 to the 10 year. Remember that for each distance the velocity is a constant. If we assume this, we're gonna have this one. Actually, this is not that accurate, because what we know about the universe, of course it's expanding the universe, but the expansion of the universe is accelerating. So we cannot use this the calculation. But if we assume the velocity, recession velocity is constant, then we're gonna have this value. This is the idea of getting the age of the universe.